Speak to your friend about it, guys. So this circle, x squared plus y squared is equals to 9 was shifted 2 units downwards and 7 units to the right, right? So, and also guys, remember you're doing it together, so stay in your lane, stay on your lane, right? So the other one is for the vertical shift, the other one is for the horizontal shift. So, is anyone else lost here? Nothing. Okay, so let's see. Do you guys think you're correct? I don't understand. You also don't understand, Hannah.
It was first. Yeah, and then it shifted 7 units to the right.
What do you think?
You minus when it's to the right. And then when it's down, then you minus.
Oh wow, interesting. Rhino? See something, Rhino? Are they doing it correct? Think so?
I'm not really right.
Hey guys, please explain what you did there. Someone explain. Someone explain. Guys, please give Rhino a chance. Okay?
What we actually did, so we first simplified our equation there. We divided by 3, and then we got this one. And so we completed the square, took the 11 over, and and then we got. and then
Rhino, okay, I understand that they are intimidating, right? We understand that. Them. Yeah. You see Rhino is agreeing. Guys, please don't look at Rhino funny. Okay. Okay. So what did you do, Rhino?
Yeah, we got to this, and then we know that this is the x coordinate of your circle. It's on one point, and that's the y coordinate. That c is -1 and 2, and r is 4.
Looking at all the numbers of x, and then we're looking for L of x is this one, right? So what we are doing is checking where either one of them is positive and the other one is negative, right? So you can know from here the x is negative and this one is also negative, so it's going to give us a positive. So we don't look at that one. We know from here to here x is negative and this one is positive. So we are going from negative root 5, right, to 0. Then we continue. Here it's positive, and here it's also positive till here, right? And then we know from root 5 to infinity, it's the x is positive, and then the L of x is negative. So we also want to include this. I don't know if that
Makes sense.
It does not make sense.
Okay, can I say something?
Explain it.
So basically, what's piece of what?
Which data are you looking at and which one?
No, they're asking for the x values. That if you multiply them with the y values, that your answer is going to be a negative. So you're going to look for the either your x value has to be negative and then your y value be positive, or your y values are negative and x values are positive.
But
Because
also-
I
Understand that.
And also, guys, you must note this down, that you must not include 0, because
Yeah.
if you see here, this one it should be. You mustn't include 0, because if you include 0, then which means you're saying it's equals to 0. And the other one is x is what?
Greater than.
Equal.
I know you look at this one. Where's the second one that you look at?
no, this is not the second one. This is the x value. And then
This is x value of one.
And
What's
also,
up?
guys,
Okay, guys, let's give Twister the last few seconds. Calm down.
yes, should say union.
Just say all. Just write all.
So that's how the graph looks.
So what's the next? Scholars.
Okay, so
Guys, what do you think of Twister's
okay,
questions?
let's substitute a negative number here.
Who says it's not possible?
It's gonna be positive because this is
Let me disappoint her.
this whole thing. So you have to think of it like, okay, let's say substitute any number that's negative. This thing is going to be positive, right? And then we add plus 2. And we know if we have a greater denominator, this whole thing becomes less and less. Because indirectly proportional, right? And also the same applies with the positive numbers that you substitute. But then when you substitute 0, you have 3, right? But then if you substitute any number that's greater than 0, this is gonna be 2 point something, and it decreases to 0. 1.2.
Okay, Ken, I think that's it.
Someone take a picture.
So you can leave
Picture is my brother.
Someone take a picture. Someone take a picture. I'm not even wearing a mask. Nice, not okay. Okay, guys.
As knowing that the center is origin, it means that the equation will be x squared plus y squared, which is equal to r squared. Then the second thing was r is root of 45. So we will have x squared plus y squared, which is equal to root of 45 squared. From there, they said the x value is twice the x value is twice the y value. So where we have x, we'll put 2 times the y value. So it will be 2y squared plus y squared, which is equal to square root of 45 squared is the same as 45. So from there, you can simply solve for y.
Zero circle. Where, how are you? Okay, it's a circle. Is Nazrin right, guys? Okay, let's look at Muhammadi's one. Is it a circle, Muhammad? Is it a circle? Are you sure? Is he correct? 19. Let's see. No, just relax. Man. Just relax. Nobody's gonna laugh at you. You're not worried about that. What are you worried about? I know I've heard about it, man. Wait, guys, is Tembeka correct there? Is she correct? Did you see how she? Okay, cool. Please come, Tando. Erase Tembeka's writing there. Just erase it. Get rid of it. Okay, the last question for AJ. AJ was given a circle centered at the origin with radius of 3. The last question for AJ, you need to show that a point is on the circumference of the circle. Right? You need to show. So AJ, the point that you're showing is A is negative the square root of 4, comma, the square root of 5. That is the point that you are showing, whether it's on the circle. Negative the square root of 4, and then the square root of 4. Who volunteered for this question? You can please read it.
No, I'm Afrikaans.
Are you Afrikaans? Oh my God. Afrikaans. Okay, guys. So basically, we are given 2 terms. Okay, so basically we are given 2 terms. The second term, T2, is equals to a half. Right? And then we are given, that's T, is it T4 or T9? No, it's T9. T9 is equals to 64 for a geometric sequence. And then determine A, R, and Tn. Okay, cool. You can, for 62, I think it's also Afrikaans. Okay, guys, cool. So they give you 2. Oh my God. Okay, guys. So they give you 2 numbers, T2, the second term, and T9, right? And then they say for a geometric sequence, and then they ask you to find A, they ask you to find R, and they ask you to find Tn, right? Okay, cool. So basically, this is not one of those ones that you guys are used to, where you just have a bunch of terms in a sequence that you can just, do some funny things and stuff. But here you must just, think a bit, right? In the sense that for T2, okay, let me just also put it out there. If you've received what you came for and you feel like you wanna go, please do it. Please, guys, don't, fake that look, the internet. Okay, cool. For the second term, we know that for geometric sequence Tn is equals to A multiplied by R to the power n minus 1. You guys know how to derive this, right? No. Yes. I know it's maybe 3 marks or 4 marks, but do you know how to derive this? If they say derive the nth term of a geometric sequence.
No.
Okay, let me just put it out there. No. Okay. Before those of the no's must just tell me. Okay. No. Okay, guys. For the second term, we're going to substitute here. So for T2, it's going to be A multiplied by R. When it's n, we're going to put a 2. So it's 2 minus 1. Then this T2 has got a value that equals to what? Half. Yes. It equals to half, right? So we can simplify this even further. 2A multiplied by R. Then 2 minus 1 is 1. So this equals to 1 over 2. Right? Is there anyone who's still in the desert? We don't know what's going on. Okay. So, and then again, we've got the 9th term, right? Okay, so even here, we're going to do the same thing. Let's just ask someone to just, Namsa, what do you think? What do you think here?
I think we'll go to do the same thing, it's just that we're going to substitute n with 9.
Yes, n with 9 minus 1. Then this, on what value does it have?
It's 64.
Good. 64. Okay, guys. So it's A R to the power what? 8. This equals to 64. Okay. So now, guys, you are back in question 1. In question 1 of simultaneous equation, right? Those they always come, like weird stuff like this, everywhere. Okay. So basically, you must find a way to solve for A and R. You are done now with sequence and series, but you're left in solving for, imagine this is Y, this is X and Y, whatever, right? So you look at the two equations and actually think of the best way to solve this thing. So if you look in this equation and this equation, the best way that you can use to solve this is to divide the two equations, and that can result into a simplified version of, the entire thing. So take this as equation 1 and this as equation 2, right? So basically, you're going to divide the second equation 2 divided by equation 1, right? Okay, so is there anyone who wants to come and divide?
Can I tell you?
This down.
So, do you want to do it like, okay, times r to the power of 8 is equal to 64 divided by a times r.
Like what you made.
Divide, yeah.
Where's divide?
A underneath, like yes.
Okay.
And then 8 times r is equal, and then 64 divided by r.
No, 2 equals.
Okay. Divide, okay, cool.
So then the a is cancelled, eh?
Okay, the a is cancelled, but big divide, Yes. Yeah. Okay, but nobody's gonna penalize you for saying that. You obviously studied an oral exam. So yes, they divide. Okay, 8 divided by 8. Okay, they divide. And then what happens? So you have to divide r to the 8 divided by r to the 1. So this equals to what, guys? 128. Is there anyone who's like, what in the world? Where are they getting the 128? Are they
Magicians.
Oh, you guys have the calculators. So this, Reina has already calculated it. Now using his calculator. This is going to be 64 multiplied by 2 over 1. Ne? So that's 128. Okay, guys. So what is going to happen here? Now, guys, listen. We finished with sequence and series here. Ne? Then now we are here. So here, continue.
Or 8 to the power minus 1. Yeah. Oh, yeah.
Like this.
Yes.
Okay, is she right, guys?
Yes.
Okay, cool. So we are left with r to the power 7 is equals to 128. Then what do we do from here?
No. I didn't the factors.
What do you mean?
So like you write the prime factors, which will be 2 to the power 7.
Okay, but how do you get that? Okay, but you guys are allowed to use calculators, right?
Yes.
So please enjoy that freedom while you still have it, because next year, it's not gonna be there, right? Okay, cool. You can find the 7th root of 128. Do you guys know how to do it?
It's 2, sir.
It's 2. Wait, is there anyone else who doesn't know how to do that? Is there anyone who doesn't looking at me as if I sure know. Sure you know. Yeah? I guys, do you know how to do that? Yeah, on the calculator, just write something like this. The 7th root of 128. Do you know how to do that, right?
Yes.
The name, do you know how to do that?
Yes.
Yeah, you don't look the part. Don't be shy, guys. This is a safe space. Anyone who tries to tease you, we're gonna throw him out. Or throw her out. Okay, so this is gonna be r to the 7 is equals to 2 to the 7. And then since the exponents are equal, it means that r is equals to 2. Ne? Or you guys could have easily done this with a calculator and just did this, the 7th root of r to the 7, the 7th root of 128. This is going to be r, and then this is going to be 2, right? And then, r is 2, and then a, wait, what in the world is going on? What in the world is going on? Okay, wait, just a second. Okay, so we're able to find our R, ne? So how are we going to find our A now? Substitute on this formula, right? So, yo guys, I think this thing I'm going to the most here. Okay, so we're going to substitute R equals to 2 here. So it's going to be A multiplied by 2. This is equals to half, right? Okay, and then what do we do next? Okay, so A is equals to half divided by 2. Do we do this? Then A is equals to half multiplied by 2 over 1. Is it that? Is that correct? Is that correct? No, it's not correct. Okay, so this is half times half, right? So A is equal to a quarter. You guys get that? So what is your Tn now? Tn is equals to A. What is A? 1 over 4. What is R? 2 to the power? N minus 1. So you can leave your answer there. But take note, guys, that this is not the most simplified version of this answer. Yeah? Do you know that? It's you guys, I think you don't have those questions where, or do you? No, you have to solve everything. Or you've got block answers, so you must just write the final answer. What is block answer? Block answers is when they write a question, they don't care how you did it, but they want the final answer. Okay. You don't do such thing, right? It says that you must take it to the Okay. Who did you get it now?
Yes.
Okay, thank you. You're welcome. Which one AJ is life-threatening to you?
Maybe that.
Which one?
Everywhere you see this thing.
Everybody see the same one. Yeah. Erica, is it fine if I just wave it out there? Is it okay? Yeah. Okay, cool. So you guys know that it's Tn is equal to an squared plus bn plus c. Eh? That is standard. We are dealing with quadratic stuff. Eh? So you're gonna have your first 4 terms, right? You just need only 4 terms. You can have 5 if you want. You just need only 4 terms in order for you to establish that. So you're gonna have the first term where there is n, you put a 1 everywhere. Then you're going to get T1 is equal to A plus B plus C. Ne? And then for T2, you just substitute 2. Then just substitute. Then you're going to get T2 is equal to 4A plus 2B plus C. Do you guys get that? Yeah. Substitute. So that, okay. And then after you have substituted all of your T's, you just need 4 values. You know, if you have time and you really want to impress the examiner, you can substitute until whatever. But 4 terms are enough, man. And then after you put those terms here, as if they were actual terms, né? And then now you find the difference between this one and this one, this one and this one, right? Then you're gonna obviously simplify them. You see this 3a plus b. Most of you guys use it when you're finding your Tn for a quadratic whatever. But you don't know where you get it. You just crammed it somewhere. Like, no, it's a plus b plus c is equal to 3a plus b. You just crammed it, but this is where it comes from, right? Yeah. Okay, so basically it results into this. And then from there, you also take, this is the first difference, right? Remember for arithmetic sequences have got a constant first difference. And then you take another difference there, and then you get this. Then if you get 2a here, then you get 9a here, just know that there's a lot going on, you know, you just need to go back again, right? So with this, you have proven that this guy has got a constant second difference. Do you guys see that? Yes. Erica, does it ring a bell? Well, you might just want to hug the paper. Let it sit next to you. Okay, guys. Please, these are the basic things that are we together, guys? Is there anyone who looks creepy and so on? Okay, guys. Okay, so basically, the quadratic one, you guys know how to do that. There is this one that sort of plays the quadratic thing in an interesting way. It's more or less like, yo, man, how are you guys able to see? Or you pretending? Corinne and AJ, how are you guys think? Yo, man, that's so bad. Guys, please don't pretend. You must just tell me if you can't see stuff. Where are my glasses?
You need glasses.
Yeah, just give them to AJ and come here with that. I don't think I'm kidding. Okay. Okay, guys. You know that when you've got your quadratics, if at any means I sort of lose you, just, it's not a crime to raise your hand. Okay, so let's say you're given 4 terms in a quadratic. You know that you're going to find the difference, right? Then you're going to get this value and this value and this value. Then you're going to find another difference, This and this must be equal. If you say it's a quadratic, they must be equal. Even if it's in terms of x or in terms of y or in terms of p or in terms of, I don't know, r for Rhino or, and then k for Camo, whatever, they have to be equal. Right? That is very much important. That's why I said to you guys, the basics, they always conceal them in something that you would think that, okay, cool. So these things must always be equal. This is the ones where you normally say a plus b plus c is equal to whatever, 3a plus b is equal to whatever, 2a is equal to whatever. These guys, it comes from that question that Erica was asking about. Okay, so this one now is a bit different in that they never placed the terms like a bunch of terms. They just wrote that the first term is equals to 4, the third term is equals to 34, the common difference is equals to 10, and then they told you that this is a quadratic. Okay, so having seen this, all of you guys in this room, can you be able to do that and find the first 5 terms of this sequence?
Which room?
In this room.
Oh.
Yeah.
Yes.
Who can? It's not a shame, guys, to say no.
They must talk.
You look at them, they must talk. Guys, please, it's not a shame. We're all here for each other.
I can interview.
Yeah.
Argument difference means
Wow, so
Sorry, what?
argument difference means second difference.
Yes. I mean the second difference. Okay, let's have a volunteer rather. Okay. Let's give it up for Lisa, guys. Give it up for Lisa.
You can do this way. You can do that.
Yeah, just try to be brave about it because I can see who else? No size trying to hide there. Yeah, no size hiding. So what?
It's like
if you are able to establish this, these are the most basic thing. Before we leave, we must have done the finite arithmetic series, the finite geometric series, and the infinite series, right? And then there are sums that you need to be able to derive. It's quite important also. You must be able to derive them. Those ones are like those 5 marks or whatever. And a number of people leave them hanging. Can you see what Becky is doing?
yes.
Who's not impressed? Who is impressed? Okay, let's just continue. Continue doing this stuff. Please be patient with you. By the time you leave today, What time is people's check-in?
8:08.
8:30. What time is it now?
It's 5 minutes to 8.
Okay. Even if we leave, I think I'm willing to stay at most until 10:30. At most, I'm not exceeding that. So just relax. When you go for check-in, you're gonna take a bit of a break. Go shower, you shower. Don't be shy. The fact that you are quiet doesn't mean you are dead. The fact that you are quiet doesn't mean you are dead.
Yeah, he's doing tickets. High five, Lise.
Do you trust him?
I know.
Okay, let's see. Okay. Then what was the question?
What are the 5 tens?
Find the first 5 tens of the sequence.
And then you can find that from me.
Okay. Okay, so T1 is 4, T2 is 5 times, what is M? 2, and then squared minus 5, and plus 4. Yeah, just do that. The 2 squared is 4 multiplied by 5 is 20, minus 5 times 2 is 10, plus 4, that's 14. This is right. So T1, T3, what is T4? Let's check T4. Yeah, Lika seems correct, man.
It seems.
Huh?
64 T4.
64. Then what is T5? Check T5.
It's 104.
104. This is quite correct. This is the same thing, but I think it's a bit, I don't know, maybe exaggerated for some of you. But it's more or less the same thing. But do you see what Lika did, guys? Lika just knew that I'm given the first term, and then he substituted, for n, he just placed a 1 and stuff like that, and he had his own equation. And then for the third term, we also substituted n there. Where is your Tn? Okay, you know that we've got Tn is equals to an squared plus bn plus c. So Lika substituted that. 3 here, so you had the 9. This is a 9, guys. It's not a8, man. So 3 squared plus b times 3, yeah. That's it. Then, Lika has such an interest for simultaneous equations, so voila, So this one, I used the process we normally use. I just took the things as they were given, then I used the normal process. Then at the end, here, wait. Was there a point later where you used this?
Yes, 2a is equal to 10.
Let's see.
And then next, fourth step.
Okay, sure. Okay. So I used the, the normal route, like having the terms, but my terms was like 4, T2, 34, T4, T5, and then after I did the things, in as much as my difference was in terms of T's, 4s, and T whatevers, but I continued. But what I knew at the end is that this, even if it's negative 34, but it has got equals to 10, this must equals to 10, this must equals to 10. I knew that, then I used that to find the T, but later is also correct. So you guys get it? So if you get it in the exam on Friday, you guys are gonna kill it, right?
I don't know.
Yes, sir.
Please guys, don't be shy, speak now, or whatever hold you peace. Geometric sequences, you know that there's a common ratio and stuff. Okay, let me see. Geometric mean, guys, we have passed there. Is there anyone who still have sleepless nights with geometric mean? No? Okay. So this is quadratics. Okay, let's come to series now. Yeah? Okay. What's a series? Because you know what's a series, right?
Plus and minus.
It's the plus and the minuses. What do you mean?
Yes, you said it, right?
Okay, check me. We've got sequences. Sequences is just a bunch of, terms. This term, comma, this term, comma, this term, comma. But now, in series, we are introduced to a phenomenon which we never saw in sequences. Series introduced us to addition. It introduced us to summing things up. You know what I'm saying? And so to better sum these things up, there is a notation that we love so much. It's called the sigma notation. All right? So, okay, the series in general, we've got this guy here called the sigma notation that we normally use to sum stuff up. Né? And then a sum can also be represented as n, Sn, which is the first n terms and stuff like that. You guys know that? Okay, cool.